Okay, so welcome back. This is part 15 in our series where we show you how to program your bench test equipment, your signal generator, your oscilloscope. And I encourage you to look at the previous videos. We're using Visual Studio and we're using C#, but you can use whatever software you want. And we started out in this series showing you how to build this application with the first set of functionality, which is being able to do a frequency response analysis on a circuit. And to do that, we showed you how to control the signal generator and also the oscilloscope, where we varied the frequency of the signal generator and then used the oscilloscope to measure the output of your circuit and to plot that as a frequency response graph. I encourage you to look at that. And then we added functionality to what you see here, where we are grabbing what's on the screen of our oscilloscope and we're updating, and as you can see here, every 0.2 of a second. And we are grabbing channel 1 and channel 2 in real time from our scope. And in the last video, we showed you how to adjust, using these two buttons, the time scale. So I can zoom out by hitting this right arrow and change the time scale, or I can zoom in to get a smaller time scale. In this video, what we're going to do is we're going to take the next step, and we're going to show you how to adjust the y-axis or voltage scale for each of the channels. Now keep in mind the x-axis, there's one x-axis scale on your scope, but you can adjust the different channels individually, and we're going to show you how to do that in this video. So here I've got my channel 1, I'm measuring the frequency and the volts peak to peak, and that's in blue. And I've got on the left, I've got the voltage scale for channel 1, and then I've got channel 2, I'm measuring the frequency, and then the V peak to peak for channel 2. And on the right hand scale, the secondary y-axis, you can see we've got a different scale. So what we're going to do is we're going to show you how with these buttons here, we've got 4 new buttons, we can, for example, hit the plus button for channel 1, and that increases the volts per division. And we can hit it again and increase the volts per division, or decrement that and get fewer volts per division. And we can do the same with the channel 2. So we're going to show you how to do that in this video. Now, as we do in all our videos, let's first design this and think about how we're going to do this rather than just doing what a novice would do and jump in and start writing code. Well, the first thing we can see is we're going to have 4 new buttons, and the event handlers of these buttons are going to choose whether we increase or decrease the scale of each channel. So how would we increase or decrease the scale? Well, as we did in this x-axis scale in the previous video, the first thing we have to figure out is we're going to have to know what is the existing scale. All right, we're going to have to know, well, do we have 2 volts per division existing scale, or do we have 5 volts? Because these just increment. So they take the existing scale and go to the next scale, either higher or lower. So the first thing we have to do is we have to ask the scope, hey, what is the volts per division for channel 1? Or what is the volts per division for channel 2? Once we know that, we can say, okay, we know what the existing is. What are the other available scales that we can go to? And we kind of did that with this x-axis. And the way we did it is we grabbed the values available from a CSV file. There were a lot of values available in the x-axis scaling. And we also had this CSV file to help us with this auto scaling on the x-axis. In this video, we're going to take a different approach, and you can choose which one you want to do, and we're just going to show you how there's a different approach. With the Y voltage scales, if you look at the scope, you can see that there's only, in our case, about 13 possible values to turn the Y-axis scale knob. So what we're going to do is we're going to save those values. We're going to find out what they are, and we're going to save those in a list internally rather than using a CSV. And as we found in the x-axis scaling, the y-axis scaling is based on 1, 2, and 5 increments. So you go from 1 volt to 2 volt to 5 volt to 10 volt to 20 volt to 50 volt and so on. We're going to come out with a list of those 13 possible values. So then we can find out what's the existing scale, check it against those 13 possible values, and see where we are and where we can go next. Since this is going to be a fairly simple algorithm where we just check the existing scale and then find out what's the possible values we can change to, what we'd like to do is make one method that can handle increment, decrement, and do it for either channel. So we're going to look at one single method, and we're going to have to feed it. We're going to have to tell it, okay, channel 1 or channel 2, and we're going to tell it either increment or decrement. So again, we hit the plus to make it more volts per division vertically, and the same with the orange. We go to higher volts per division, and then negative means fewer volts per division. So let's look at the code and see how we can implement this. So here we are in our application. I've taken those 4 buttons and made event handlers by double clicking on the button. I'll let you figure out how to do that. It's pretty straightforward. Right here you can see I've got 1, 2, 3, 4 event handlers for those 4 buttons. I've got called BTN channel 1 increment, BTN channel 1 decrement, BTN channel 2 increment, and BTN channel 2 decrement. And as I mentioned, I'd like to have one method that I can use for all of those. And what I'm going to do is I'm going to set up a method called change scope vertical scale, and I'm going to feed it the channel number and also a number indicating whether I want to increment or decrement the scale. So for channel 1 increment, I'm going to feed it a channel 1 and a 1 for increment. And I'm going to run the same method for channel 1 decrement, and I'm going to say channel 1, and I'm going to feed it a 2 to say decrement. Same thing for channel 2. I'm going to feed it a 2 for the channel number and a 1 for increment, or I'm going to feed it a 2 for the channel number and a 2 for decrement. We're going to have one method that does everything. So let's go take a look at that method. So here is the method, private void change scope vertical scale, and I'm feeding an int for the channel number and an int for whether I'm going to increment or decrement. And this is all the code. So what I'm doing is this method increments or decrements the Y voltage scale for a given channel. It takes a channel number and an integer which specifies whether to increment or decrement. And I'm going to say a 1 means increment, and any other number that I feed it in this increment decrement is decrement. You can do whatever you want, but that's how I'm going to do it initially. And this is going to reference a list which lists all available Y scale settings based on a 1 to 5 range. So let's go take a look at that. So I've got a class for all of the data associated waveform capture. You don't have to do that, but one of the lists of doubles I've got is scope vertical scales. And I'm initializing it here as a new list of doubles. And I've got the 13 possible scales. It can go 10 millivolts, 20 millivolts, 0.05 volts, 0.1, or 100 millivolts, 200, 500, and these are all the possible scope vertical scales. We're going to start out, we have a scale double, which is going to be the double version of the existing scale that we're going to read from the scope. And the new scale, we're going to initialize that as 1 volt per division, but we're going to change that. And then we're going to have this index as we step through all of these possible values to compare it against the existing. So again, as we did before, we have to figure out, we're going to ask the scope, okay, what is the present vertical scale? And we're going to tell it for what channel we want. And we're going to say the string text to write is channel plus whatever channel we fed it converted to a string. And then we use the colon scale question mark to ask the scope what's the present scale on that channel. And we go through as we showed before. We do a raw io.write, replace common escape sequences. Again, look at the previous videos on how to do this. And then we're going to read the result, which is an array of bytes, and we're going to convert those to a string called val string, and then we're going to use this try parse to convert that string to a double. And the output is going to be scale double, and that is going to give us the existing scale for channel 1. Then now that we've got the existing scale, we have to step through each of these values to compare it to see where we are in the possible range. And we're going to use a for each. So for each double, and we're going to call it scale, in this scope vertical scales, which is this list, scope vertical scales, we're going to step through that, and if the actual measured scale is equal to the value that we're at in that list, then we're going to say, okay, increment it or decrement. So if increment is 1, so in other words, we want to go to a higher volts per division, and we also have to check to make sure we're not at the end of the range of these values. Because, if we're at 100 volts, we don't want to increment to the next because there is no other. And same for the 0th value. So we're going to check to make sure that we're below the top of the range, which is wave data scope vertical scales.count -1. So we don't want to increment past the top of the range, so we're going to also do that check. But if we're okay, we're within the range, we set the new scale equal to the scope vertical scales +1. We set it to the next element in that range of possible values. However, if we want to decrement, else if increment or decrement is not equal to 1, again, anything other than 1 is going to be a decrement, and I is greater than or equal to 1. In other words, we're not at the 0th element in the value, we're at the 1th element, because if we're at the 0th element, we can't go down to 0 minus 1th element because that doesn't exist. So we're going to make sure if we're at the 1th index element, then we can still decrement down. And then we're going to say new scale equals the scope vertical scales I minus 1. However, if none of those is true, we're just going to set the new scale equal to the existing value and move on. We've set up this incrementer, and then we're going to increment that and check the next one. So now we've got the new scale, and what we need to do is figure out how to send that. And that's very easy. We're going to send the new vertical scale value to the scope. The string we're going to use is channel plus whatever channel we have. Convert that to string, then append the :scale, and then the new scale is going to be space new scale, whatever the new scale value is. And that's going to be the string that we send. And then MB session raw IO write, replace common escape sequences, and we're going to use that new scale. So this is a nice compact method that allows us to use multiple channels and decide whether we want to increment or decrement. So that's about it for this. Not sure where we'll go in the future for this application. If you have any thoughts, let me know. If you like any of these videos, please hit the like button, subscribe, hit the bell notifications, but most of all, please let others know that we're here so we get some views. Really appreciate it. Otherwise, take care. Have a really good day. Thanks.